Hello everyone, welcome to yet another video from me. I'm Damian, math tutor from Busan Tuition 30. So in this video, I'm going to go through the Form 4 Chapter 8. So without wasting any more time, let's go to the questions. Alright, let's look at the comprehensive practice for Chapter 8. Question 1. So calculate the range and the interquartile range for each set of the data. So range and interquartile range. Range and interquartile range is quite easy to find. Range is very easy. It's just the largest number minus the smallest number. While interquartile range, we have to take the upper quartile minus the lower quartile, or the third quartile minus the first quartile. So in order to find the interquartile range, to find the quartiles, we need to first arrange all these values in ascending order. Okay, I need to arrange all of this in ascending order. So how do I do that? Basically, we first arrange in ascending order from lowest to the highest number. 8, 11, 16, 18, 22, 24, 25. So the largest number is 25, lowest number is 8. So range is just 25 minus 8, which is 17. That's the range. And then the interquartile range, we have to find the median first, the middle number. Middle value is here. That's the median. So to the left of the median, I have these three numbers, 8, 11, and 16. I find the middle of that, which is the 11 here. That's the first quartile. The right of the median, there's three numbers. The middle of it, 24. That's the third quartile or upper quartile. So interquartile range will basically be 24 minus 11, which is 13. So that's the range and interquartile range. That's for part A. Part B, same thing, arrange in ascending order. So 18, 27, 33, 45, 50, 62. Middle of it is here, right in between. Okay, if I want to find median, then I add these two together, divide by 2. But I don't need to find the median, I just need lower quartile and upper quartile. So to the left of the median, these three numbers, middle of it, that's the first quartile. To the right of it, middle, that's the third quartile or upper quartile. So range, highest value minus lowest value, 62 minus 18, which is 44. And interquartile range, 50 minus 27, which is 23. Yeah. C, also arrange in ascending order, lowest to highest. So actually, let's put it here. So lowest is 2.7, then 2.8. And then 2.9, 3.0, 3.2, 3.4, 3.8, 4.3, 3.4, let me write properly, 3.0, 3.2, 3.4, 3.8, 4.3. Alright, so middle of this, there are 8 numbers here. In the middle will be here in between 3.0 and 3.2. To the left of the median, the middle of it is here, right in between 2.8 and 2.9. So first quartile will be in between these two, so it's 2.85, the average. Add together, divide by 2. That's the first quartile. And the third quartile, right in between these four numbers, in between 3.4, 3.8, So 3.6. Just add together, divide by 2. So range, again, highest minus the lowest number. 4.3 minus 2.7, which is 1.6. And interquartile range, 3.6 minus 2.85, which is 0.75. Then the part D. Again, lowest to highest number. So lowest I have 12 and another 12. 12, 12. 15, 16. 17, 17, 18, 18. 17, 17, 18, 18, 19, 20, then 22, 30, 32. 22, 30, 32. Okay. So there are 13 numbers here, right? In between will be this number. Yeah, so you see 6 numbers on the left, 6 numbers on the right. So in the middle of these 6 numbers, in between 15 and 16 is your first quartile, 15.5. In the middle of these 6 numbers, in between 20 and 22, 21. That's the third quartile. So the range, highest minus lowest value, 32 minus 12, 20. And the interquartile range, third quartile minus first quartile, 21 minus 15.5, which is 5.5. That's the range and interquartile range for each of these values. So we always arrange in ascending order, find the middle, then to the left of the middle, find the middle of that, to the right of the middle, find the middle of that. That's the first quartile and upper quartile. Yeah. Okay. Next, we have a table here. I want to find range and interquartile range for each of this. Again, I want to find range and interquartile range. So, range is very simple. Okay. So for part A, range, I can just take highest value minus lowest value. Means 7.2 minus the 6.0. So it's 1.0. Yeah, same goes for B. The range is very simple. Highest minus lowest value, 18 minus the 13. I get 5. So interquartile range is not so simple. Basically, we have to get the cumulative frequency. Okay, means I accumulate the frequency, I stack it up. So I start with this 6, then I keep adding the next frequency. 6 plus 9, 15, then 15 plus 12, 27, 27 plus 18, 45, 45 plus 20, 65, 65 plus 10, 75, 75 plus 5, 80. So what I have to do is, it's called first quartile and third quartile because it's 1 quarter and 3 quarter at the 1 quarter point and 3 quarter point. Okay, for the values. So I take 1 quarter of your total frequency and 3 quarters of the total frequency. 104 times 80 is 20. 3 quarters, 3 over 4 times 80 is 60. So what we want is the 20th value and the 60th value for the first quartile and the third quartile. Yeah. Okay, so how do we find that? Basically, the cumulative frequency tells you it stacks up to value number 1. So basically 6 means frequency of 6 means there is 6 repeating 6 times, and then 6.2 repeats 9 times, and then 6.4 repeats 12 times like that. So from the first value to the sixth value is your from first value to the sixth value is 6.0. Then from the 7th value until the 15th value is the 6.2. And then from the 16th value up until the 27th value is your 6.4. So that's how it works. So if let's say I want the 7th value, then I take 6.2. If I want the 9th value, it's 6.2. Yeah. Okay. So in this case, if I want the 20th value, means is after this 15th value, means it goes up to the 6.4. And the 60th value is 6.8. Yeah, so interquartile range is 6.8 minus 6.4. I get 0.4. Yeah. Same goes for the B. I find the cumulative frequency. 12 at the next one, 12 plus 18, 30. 30 plus 21, 51. 51 plus 20, 71. 71 plus 21, 92. 92 plus 8, 100. So first quartile value, basically I take 1/4 times the total frequency, 25th value. Third quartile would be 3/4 of the total frequency, 75th value. So 25th value means 14. 75th value is after the 71 here, so 17 means interquartile range. 17 minus 14, which is 3. So range is 5, interquartile range is 3. That's question 2 here. Then we proceed with question 3. Calculate the variance and the standard deviation for the following sets of data. So now I want variance and standard deviation. Okay, variance and standard deviation, there's the formula that we can use. Formula is given. If we're given single values like that, basically I just write the standard deviation formula out. Is square root of sum of x over n minus mean square. Yeah. Sorry, sum of x square over n. Yeah. So total of the x square, each value square add together. And to find the mean, add everything, divide by number of values. This is standard deviation. If I want variance, means without the square root. So first, let's find sum of x and the sum of x squared first. Okay, so basically, we just need to add up all the values. 7 plus 9 plus 11 plus 8 plus 3 plus 7, and I get 45. Sum of x squared means each value square. 7 square plus 9 square plus 11 square plus 8 square plus 3 square plus 7 square. Then I get 373. Number of values, there are 6 values here. So I can find the mean first, or I can straight away put it in. Okay, it doesn't really matter. Let's just say I straight away count. So variance will be sum of x squared, 373, divided by number of values, 6, minus mean, 45, divided by 6, square. Yeah. Okay. If you want to count the mean first, you can. And you just take 45 divided by 6 first. Which is 7.5. Yeah, so minus 7.5 square, like this. If you find it easier to key in like this, then by all means, you can count the mean first. So you get 5.9166, so 917. Okay. And standard deviation, basically, we just square root your variance. So square root answer, I get 2.432. Yeah. Okay, that's the variance and standard deviation. So that's part A. So do the same thing for all the other parts. Part B, again, I find sum of x squared. 50 plus 72 plus 63 plus 58 plus 55 plus 50 plus 70 plus 62 plus 66 plus 64. Yeah, so it's 610. So if you find it hard to key in all over again, you can actually press right until you go to the correct point, then you just put the square, right? Square. For each of this number, I square. Yeah. Then as you do that, you can double check the numbers whether you key in correctly or not as well. Instead of keying it in all over again, this kind of saves a bit of time. So it's 37,738. Yeah. So let's say I find mean first. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 610 divided by 10, 61. So variance 37,738 divided by 10 numbers minus 61 square. So 37738 divided 10 minus 61 square. Okay, which will get 52.8. Okay, 52.8. Yeah, that's the variance and standard deviation. Basically, we just square root. The calculator kind of hang a bit. Yeah, 52.8. I square root the 52.8 and I'll get 7.266. Okay, that is the variance and standard deviation for B. For C, again, repeat the same steps. Sum of x squared. Each value plus together. 3.2 plus 4.4 plus 3.9 plus 4.1 plus 5.2 plus 4.8 plus 5.2. So you get 30.8. Sum of values square. Each of the number I square. 3.2 square, 4.4 square, 3.9 square, 4.1 square, 5.2 square, 4.8 square, and 5.2 square plus together, which will be 138.74. And the mean, 30.8 divided by, there are 7 values here. 30.8 divided 7, 4.4. So variance 138.74 sum of x squared divided by number of values 7 minus mean 4.4 square. 138.74 divide 7 minus 4.4 square. So you get 0.46. And standard deviation, square root of the 0.46, 0.6782. Yeah, 0.67823, so 0.6782. Yeah. And for part D, same thing as well. First, we list out sum of x squared. So 20 plus 27 plus 32 plus 47 plus 50 plus 38 plus 42 plus 40 plus 33 plus 37 plus 30. 396. Then each of these values I square. 20 square, 27 square, 32 square, 47 square, 50 square, 38 square, 42 square, 40 square, 33 square, 37 square, and 30 square. 15028, 15,028. Mean 396 divided by, here there are 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 11 numbers. 396 divided 11, 36. Then variance, sum of x squared over n 11 minus mean 36 square. So 15028 divide 11 minus 36 square. 70.1818, so 70.18. And the standard deviation, square root of that, I get 8.3774, so 8.377. Yeah, that's how we count variance and standard deviation. Yeah. That's question 3. So we move on to the next one, question 4. Variance and standard deviation as well. Okay, but now I have I'm not given all the values. I'm straight away given there are 7 numbers. Means n is 7. Sum of the 7 numbers is 84. So that is the sum of x. Sum of the square of the numbers, that is sum of x squared. So I want to find variance and standard deviation. So since I'm already given all these values, straight away I can use the formula. Variance 1920 divided by number of values minus mean square. So let's find mean first. Mean is 84 divided 7, 12. So minus 12 square. So 1920 divided 7 minus 12 square. 130.28, so 0.3. And standard deviation, square root of that. So I get 11.414, 11.41. Yeah. Okay, so this is very, very simple. Very, very straightforward. Then we look at question 5. Range and standard deviation of set of numbers x1, x2, x3 up until x10 are 10 and 5.2. So I want to calculate range and standard deviation of this new set of numbers. Now, what happens is when we plus or minus each of the values in the number, the gap between them will remain the same. Okay, imagine if I have 1, 2, 3, 4, 5. The gap between 1 and 5 is 4. If everything at plus 3, let's say, so 4, 5, 6, 7, 8, the gap between first and last number is still 4. So the gap between them doesn't change, and range and standard deviation, basically your measures of dispersion, is the gap between your values. So the gap doesn't change if I plus minus because it just shift up and shift down. The gap between them doesn't change. But when I multiply and divide, then it will change in exactly the same way as how you multiply and divide. So if we look at this, part A, range and standard deviation of this new set of numbers, 2x1, 2x2 means each of the values I times 2. So the range and standard deviation will also times 2. 2 times 10, 20. And the new standard deviation, 2 times 5.2, 10.4. Yeah. For B, again, plus minus will not affect it. So only the divide 4 will affect it. So the new range will be the old range divided by 4, 2.5. And the new standard deviation will be the old standard deviation divided by 4, 1.3. Just like that. Okay, that's what happens when you change each of the value inside the data, inside your set of numbers. Now we look at question 6. Masses of a group of 8 pupils, okay, have mean of 45 kg and variance of 2.5 kg. I want to calculate sum of mass of the 8 pupils. Sum of mass means sum of x. So sum of x, basically I use the mean formula because mean is sum of x over n. As long as you have n and the mean, I can find sum of x. As for sum of x squared, I need to use the variance or standard deviation formula. Depends on what is given. In this case, we're given variance, so sum of x squared over n minus mean square, this formula. So for part A, mean is 45 equals sum of x over 8 pupils. So n is 8. So means 45 times 8 is the sum of x. Sum of x will be 225. Okay, sorry, why did I times 5? Times 8. Times 8, so 360. Yeah. Sum of the square of the masses, so sum of x squared. So use the variance formula, 2.5 equals to sum of values square over n, number of values, which is 8 minus mean square. Mean is given 45. So minus 45 square, bring over, opposite plus. Equals sum of x squared over 8. So I count 45 square plus 2.5 is 2027.5. Divide 8 opposite times 8. So sum of value square, sum of x squared is just times 8. 16,220. Yeah. Okay, that is question 6. Now question 7. Mean of a set of numbers. I'm given all this. These are the set of numbers. The mean is 10. So they want you to find m. Basically, there are 1, 2, 3, 4, 5 values. So if I add them all together divided by 5, it should be equals to 10 because mean is 10. M minus 4 plus m plus 2 plus 2m plus 2m plus 3 divided by 5 values equals to 10. Bring over the 5 times 10. Simplify this, m plus m plus m plus 2m plus 2m. 1, 2, 3, 4, 5, 6, 7, 7m. Then plus minus 4 plus 2 plus 3 means plus 1. 7m is 50 plus 1 opposite minus 1, 49 times 7 opposite divide 7, m is 7. That's value of m. Then the standard deviation. So once I have the value of m, I can get each of these values. So put in 7 means it's 3. 7 minus 4, 3 is 7. 7 plus 2, 9. 2 times 7, 14. 2 times 7 plus 3, 17. So I find sum of x and sum of x squared. 3 plus 7 plus 9 plus 14 plus 17, 50. Actually, I don't need sum of x because I have the mean and just one standard deviation. So I just need sum of x squared. So each of the values square. 3 squared plus 7 squared plus 9 squared plus 14 squared plus 17 squared. I get 624. So use the standard deviation formula. Square root of sum of x squared over n 5 minus mean square 10 squared. Square root of 624 divided 5 minus 10 square. So it's 4.9799. So if I round off, will be 980. Yeah. You just write 4.98 is fine as well. That's part A. Part B, each number in the set is multiplied by 3 and then added by 2. Calculate the variance of the new set of data. So since this is the old standard deviation, the new standard deviation, basically again, it changed according to the same way, which is times 3, but plus minus doesn't affect. So I take 3 times 4.98. 14.94, and then the new variance, I just square the value. 223.2. Yeah. So when you change, I rather not change from the variance because variance, the unit will be the value square. Okay, so when we change from variance, basically we have to change according to the value square as well. Means instead of times 3, I times 3 square. Yeah, that's why I prefer not to change from variance. I prefer to change from standard deviation. But if you want to change from variance, then make sure you square the change. Yeah, if it's times 3, then times 3 square. If it's like divide 5 square. Like that. Okay. Then we look at question 8. Table here shows n, sum of x squared for set of data. So Part A, calculate the variance. Let's find the mean first. Sum of x over n. 66 divided 12 is 5.5. So variance, sum of x squared 1452 divide number of values minus mean square. So 1452 divide 12 minus 5.5 square, which is 90.75. That's part A. Okay. Part B, a number p is added to the set of data. It's found that the mean is increased by 0.5. I want to calculate p. So if the mean is increased by 0.5, basically what I need to do is I need to find what p is. So I can relate using the mean formula. So mean increased by 0.5. Initially is 5.5, means becomes 6. Yeah. Okay. So you can write 5.5 plus 0.5, the new mean, equals to the new sum of values, which is 66 plus the p, the newly added number, divide n. N becomes 13 because I put an extra number in. So 6 here, divide 13 opposite times 13. So 6 times 13, 78. 66 I bring over, plus opposite minus. So p will be 12. Yeah. That's B1. B2, standard deviation of the new set of data. So I know that p is 12 now. I can find sum of x squared, the new sum of x squared, which is the 1452 plus the newly added number square. Yeah. 1452 plus 12 square, 1596. Then I use that and the new mean and new n to find standard deviation. Square of sum of x squared, 1596 over n is now 13. Mean is now 5.5 plus 0.5, 6 square. So square root of 1596 divide 13 minus 6 square. 9.315. Yeah. Okay. That's question 8. Now question 9. Calculate variance of the set of data here. Okay. So let's let's add this all together. Let's find the sum of values. So p minus 4 plus p minus 2 plus p minus 1 plus p plus 4 plus p plus 9. So there's 1, 2, 3, 4, 5, 6, 6p. So 6p minus 4 minus 2 minus 1 plus 4 plus 9. Okay. Minus 4 minus 2 minus 1 plus 4 plus 9, which is 6. So plus 6. There's 1, 2, 3, 4, 5, 6. 6 values here. So if I find mean, 6p plus 6 over 6, which is p plus 1. Yeah. Okay. Then sum of values square. So So if I take each of this square and plus together, if I expand it, p square minus 8p plus 16 plus p square minus 4p plus 4 plus p square minus 2p plus 1 plus p square plus 8p plus 16 plus p square plus 18p plus 81. Yeah. If I simplify this, so there's 1, 2, 3, 4, 5, 6 p squares. And the p values, minus 8, minus 4, minus 2, plus 8, plus 18, 12, plus 12p. Then positive 16, plus 4, plus 1, plus 16, plus 81, 118. Yeah. I can factorize 6 p squared plus 2p. Actually, no, I can't factorize 6. I can factorize 3. Okay, no. I can factorize 2. Let me count again. 16 plus 4 plus 1 plus 16 plus 81. Yeah. If I factorize 2, 3p squared plus 6p plus 59. Right. If I take variance, sum of values square over n minus mean square. This will cut. Left with 3. So 3p squared plus 6p plus 59 minus, let's make this into same denominator. Put 3 here times, expand the p plus 1 square, p squared plus 2p plus 1 over 3. So it's 3p squared plus 6p plus 59 minus 3p squared. Different sign minus 6p minus 3 over 3. 3p squared minus 3p squared is 0. 6p minus 6p is 0. So 59 minus 3, 56. So I'm left with 56 over 3. That is the final answer. Yeah. Okay, so this is quite troublesome and complicating. Okay, The way of doing is actually the same, but it's very, very long, very, very troublesome. Okay. But you basically have to take it one step at a time. Okay, square each of these values. Expand it, plus all together, simplify, then put it into a formula, simplify again, combine it into one fraction, simplify again, then you will get the 56/3. Alright. Now we look at question 10. Table here shows mass of players in 2 sepak takraw teams. Calculate the mean, range, variance, and standard deviation for the masses of players in both teams. So straightforward, we find mean. For team A and team B. Actually, let's just split at that. Right. So mean will basically be sum of all the values. So we just add up all the values here. 48 plus 53 plus 65 plus 69 plus 70. 305 divided by number of values, which is 5. So it's 61. Yeah. And the mean for team B, same way of calculating. Add all together, 45 plus 47 plus 68 plus 70 plus 75, also 305. So divide by 5, also 61. Yeah. Then range, highest value minus lowest value, 70 minus 48, 22. Range for team B, 75 minus 45, 30. And then variance and standard deviation, I need sum of x square values. Yeah. So sum of values square, find for each of the team. So each of the value I square and plus together. So 48 square plus 53 square plus 65 square plus 69 square plus 70 square. 18999. Right. Then for team B as well, find the sum of values square. 45 square plus 47 square plus 68 square plus 70 square plus 75 square. 19383. So variance, sum of x square, 18999 over n, 5 values, minus mean square. 18999 divided 5 minus 61 square. 78.8. And the standard deviation, square root of the variance. So square root of 78.8, 8.8769, so 877. Yeah. And for team B, variance 19383 over 5 minus 61 square. 19383 divided by 5 minus 61 square. 155.8. 0.6. Yeah. Standard deviation, square root of that. $12.473. So 12.47. Yeah. Okay. So is the range appropriate to be used as measure of dispersion to represent the data here? So whether it is appropriate or not. So in this case, okay, in a sense, these two is quite far off from everything else. Yeah. Whereas this one are closer together. All the values are considerably close together. But this one, these three values are close, but 47 and 45 are very far away from them. So they are considered outliers or extreme values. Yeah. So it's not suitable. Yeah, it's not suitable to use range. Outliers exist in team B. Yeah. Okay. Outliers or extreme values both can be used. You can say outliers, you can say extreme value. It's fine. So mass of which team has greater dispersion from the mean? So look at the dispersion. Whether you look at range, variance, or standard deviation, all of them, team B has a greater dispersion. Yeah. Okay. That's for question 10 here. Let's look at question 11. Sum of a set of 10 numbers is 180. Sum of squares of the set of numbers is 3,800. I want the mean and variance. So I have n, sum of values, sum of square of values. So straight away I can find mean and variance using formula. 180 divided 10 for the mean. So it's 18. Variance, sum of x squared over n minus mean square. So 3,800 divide 10 minus 18 square, 56. So mean is 18, variance 56. And for part B, number 19 is added to a set of numbers. So we cannot change from the mean and standard deviation or variance, standard deviation, or that. We have to change from the sum of values and the sum of values square. The new sum of values will be 180 plus 19, 199. The new sum of values square, 3,800 plus 19 square, which is 4161. Then using this, I can find the new mean and variance. N also becomes 11. Okay, we gotta put one number in. If I take a number out, then it's minus, and also n will minus 1. So the new mean, 199 divided by 11. $18.0909. So 18.09. The new variance, sum of x squared 4161 divide the new n 11 minus mean square. 4161 divide 11 minus 18.09 square. So it's 51.02. Yeah. Okay, that's the mu mean and new variance. So to change from sum of values and sum of values squared respectively. Now we look at question 12. Here we have time in hours and number of pupils. They say there are 32 pupils. So they want range, interquartile range, variance, and deviation. Okay. Then determine which is the most appropriate measure of dispersion. So range is easiest. Highest minus lowest value. So just 10 minus 1, 9. Interquartile range, again, we need to use cumulative frequency. So 2 plus 5, 7, 7 plus 6, 13, 13 plus 9, 22, 22 plus 6, 28, 28 plus 2, 30, 30 plus 1, 31, 31 plus 1, 32. Yeah. So 1/4 of 32 is 8. 3/4 of 32 is 24. So I want the 8 and 24 value. First quartile is 8 value. So 8 value will be 3. Third quartile is 24th value, which is 5. So interquartile range, 5 minus 3, 2. Then variance and standard deviation, we need sum of values and sum of values square. So instead of sum of values square, there's frequency table here, and I need to use sum of frequency times values and sum of frequency times the value square. Yeah. So the formula becomes sum of fx over sum of frequency minus mean square. It's just the extra frequency. We have to times the frequency because that number will repeat that many times. Okay, so sum of fx means each of the values, each of the frequency times with the value square. So 2 times 1 plus 5 times 2 plus 6 times 3 plus 9 times 4 plus 6 times 5 plus 2 times 6. Six times 5, 2 times 6, plus 1 times 7, plus 1 times 10. 1 to 5. Then each of the values, each of the x value I square. So the 1 I square. Then the 2 square, 3 square, 4 square, 5 square, 6 square. Sorry. Six square, 7 square, and the 10 square. I get 591. Yeah. So we find the mean, sum of fx. Mean becomes sum of fx over total frequency. So 1 to 5 divided by 32, which is 3.906. So variance 591 divided 32 minus 3.906 square. $3.2119, so 212. Okay. Actually 210 if I take the exact value. So actually it's best to use exact number. Yeah, best not to round it off. Okay, so if it's a non-rounded value, yeah, it's better to not round it off. Yeah. Okay, so yeah, I will get this 3.2099 means 210. Yeah. Then standard deviation, just square root the value, 1.791. Sorry, 7916, so 792. So that is the standard deviation. So part B, I want the most appropriate measure of dispersion to show the time spent on revision by the pupils. So you see here, 1, 2, 3, 4, 5, 6, 7. Suddenly there's a 10 here. So it skipped until the 10. So which means there is an outlier, an extreme value. Whenever there's an extreme value, we always use interquartile range, because interquartile range will not be affected by the outlier, okay, by the extreme value. So in this case, we will use interquartile range. Yeah, reason because of the extreme value. Okay, we don't have to say the reason here, but I'm just showing it to you. Why is it like that? So yeah, basically that is for the Form 4 Chapter 8. It's all about calculating all these measures of dispersion. Right? So that's all for the Chapter 8. So again, I'm Damian, math tutor from Usa Tuition 30. So if you're interested to join us, you can buy books from us, support us, follow our social media, Instagram, Facebook, YouTube. We also upload social media reels on our Instagram if you're interested to follow. And we also offer classes online and also physical classes. So feel free to contact us through any of the means here, and we will try to reply as soon as possible. So thank you for watching. Hope you'll support me. Please share, like, and subscribe if you find this useful. Until next time, bye-bye.